Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we are looking at simplifying radicals or square roots or any other type of root, as well as adding and subtracting these roots together. Let's go ahead, let's get started here with this first problem. First thing I would do on this problem is I would start by separating it. There's really three different things I'm looking at. I'm looking at the square root of 32, the square root of x squared, and the square root of y to the 6th. So now I just want to simplify each of these parts separately, and then I can kind of put them back together at the end. The square root of 32. Remember how that process works. You can go into your calculator, you can use Desmos. Type in 32. Do not use any of the square roots when you do this. But you want to divide it by the square roots below it. You would divide it by 25. That's below it. Okay, that does not go in evenly, so we try another value. You try the next perfect square below it, which is 16. And what Desmos would tell you is that goes in 2 times. So what that tells me is I'm allowed to separate this square root into 2 separate square roots. The square root of 32 is the same thing as the square root of 16 times the square root of 2. Well, the reason we want to do that is the square root of 16. That is a perfect square, we said. And the nice thing about perfect squares is you can evaluate their square roots. So the square root of 16 is a value of 4. Notice when I change the 16 there, when I take the square root symbol is now gone. 2 is not a perfect square. You are not going to take the square root of it. The numbers have been simplified. Looking at this next one, it's the square root of x squared. If you think back to, I believe it was our 6.3 video, we looked at rewriting these radicals into a rational exponent. Meaning we can have a fractional exponent where it is the exponent of 2 over the root of 2. Exponent over the root. Okay, by doing that, then you can try and simplify this fraction. 2 over 2 is divisible. It simplifies down to a value of 1. That is just the same thing as x to the first, or you could just write that as x. Either of those work. This next one, again, it is a square root. It's still that value of 2 out front. We can rewrite it 6 over 2. That does divide. You could type 6 divided by 2 into your calculator. That gives you 3. We have all of the components of our answer. Now just rewrite it. Anything without a square root generally goes to the front. Anything inside the radical, inside the root, moves to the very end. And we'd have our simplified form. Let's look at another example of that here. There's a few different parts. There's this value of 6. There's this square root of 147. There's this square root of x to the 12th. There's the square root of y to the 9th. The value of 6, we cannot do anything with that. So the 6 is just going to stay the same. Square root of 147, do that division process we just did. If you were to go through that division, you should find 49 goes in 3 times. Whichever of these is a perfect square, you can simplify it. The square root of 49 is a value of 7. The square root goes away on it. So now I just have 7 and the root 3. X to the 12th, inside of a square root, make your exponent over your fraction. Simplify it if you can. And the y to the 9th over 2, well, that doesn't simplify. And this is where the variables get a little trickier. This is a process that can work for any radical or rational exponent you are trying to simplify. 9 over 2 does not divide. So what I'm going to do is I'm going to decrease this value of 9 into a value in which 2 goes into, and which is divisible by 2. What I know in this case is if I were to go down, I could go down to a value of 8, because 8 is divisible by 2. In fact, 8 divided by 2 is just 4. But when you do that, you can't just say that 9 magically changes to this value of 8. You have to do something that is mathematically correct. So really what we are doing here is we're splitting y to the 9 over 2 into 2 separate fractions. One that is 8 over 2, and the other one has however many pieces we got rid of. We went from 9 down to 8, so that meant our value changed to 1/2. Well, just like we did at the beginning, to go from this root into this exponent, we can now do that same process, just the opposite direction. This is a square root, so the 2 is out front, with the y to the 1 on the inside. Realize that is just the same thing as y to the 4th times the square root of y. The 2 out front's not needed, nor is the exponent of 1. Now that each of these parts are simplified, we need to rewrite our answer. Anything without the square root goes to the front. That's the 6th, the 7, the x to the 6th, the y to the 4th. Anything inside of the square root gets grouped together at the end. That's the 3 and the y. Notice in this case, though, the 6 and the 7 are both out front. Both of those values at the beginning were multiplying. The 6 was multiplying with this root. That means the 6 would still multiply with anything out front now. So 6 times 7, we would be able to multiply those together. And now we have a good answer. That is simplifying another radical there. One thing we might notice is sometimes you get these fractional exponents. Again, we just talked about the 1/2 power. 1/2 power is just the same thing as a square root. So this process now for this problem would be the exact same. You could separate it to your different parts. Simplify each of those parts. And as you simplify each of your parts, make sure that you recombine them at the end. Again, the 3 is not divisible by 2, so decrease it. However much it goes down becomes the other fraction, and then change that fraction back into its root form at the end. Group everything at the end without the square root and with the square root. And then any of your values that need to multiply, make sure you do so. So now the other thing we are looking at in this video is adding and subtracting radicals together. In order to do that, they need to be like terms. Like terms mean that they are the exact same root. Root 2, root 8, and root 50 are not the same. So let's start by simplifying each of these. Root 8 is the same thing as root 4 and root 2. Root 50 is the same thing as root 25 and root 2. So if I were to simplify each of these, I would now get something like this. When you add and subtract like terms, the only thing that changes is the coefficient, the value in front. So the root 2 does not change. It's just these values in front. Realize this first root 2 out front does have a 1 in front of it, meaning we have 1 plus 2 plus 5, giving us 8 root 2 in this case. Let's look at one more example. 2 root 28, root 14, and root 63 are different, so again, simplify them if you can. Find your perfect squares that go in. If you take 14, you divide it by the perfect squares below it, 9 and 4, you're going to find that neither of those go in. The root 14 actually does not change. Simplify this last one as well. 63 you could rewrite as 9 and 7. Continue to simplify. 2 times root 4, which would just be 2 times 2, gives us a value of 4, root 7. We said that the square root of 14 does not change. Notice these are 2 different roots. We'll keep our eye on that for later. And this last one, the 9 changes to a 3 when we simplify it, and the root 7 is still there. Combine what you can. It's not all the time that you can combine everything. In this case, the only 2 roots that match are the root 7s at the beginning and at the end. So let's just combine those. 4 plus 3, combine the values in front. The root stays the same. And the 14, we did not do anything with it. So it's just going to go ahead and follow this equation or this expression along. That is our 6.5 video. Thank you for watching. Looked at a lot of radical expressions there.